More on acceleration. So just a reminder then, what we've already discussed, acceleration is a change in velocity and the unit is meters per second squared, or in other words, meters per second per second. And you can calculate it using this equation. Acceleration is the change in velocity in meters per second divided by the time taken for the change in seconds. So on your physics equation sheet, which comes in with your exam paper, you'll find this equation, A equals V minus U divided by T. We've talked about it before, where V equals final velocity, U equals initial velocity, and T equals the time taken for the change in velocity. Or you can put it into slightly simpler language. You can make one of these lovely triangles that are so helpful. Change in velocity at the top, acceleration times time taken at the bottom, cover up the one you're looking for, and the position of the other two tell you what to do. If you're looking for the time taken, then it's change in velocity divided by acceleration, and so on. Now, what is it that causes acceleration? It's a resultant force in the same direction as the velocity causes the acceleration of a body. And the greater the resultant force, the greater the acceleration. And an object decelerates, slows down, if the resultant force is in the opposite direction to the velocity. Now, it stands to reason that a heavy object requires a larger resultant force if it's to accelerate than a lighter object does. So therefore, acceleration depends upon both the mass of the object and the size of the resultant force. And this can be put into another equation. Acceleration equals force divided by mass. And this is another equation that's found on your physics equation sheet. What you'll see on your physics equation sheet is A equals F divided by m, where A is acceleration, capital F is force, which is in newtons, and m is mass, which is in kilograms. Now this equation again can be rearranged to work out any missing part of it. For example, if you're looking for the resultant force in newtons, then it's mass times acceleration. If you're looking for mass, it's resultant force divided by acceleration. So again, what you'll actually find on the physics equation sheet is F equals m times A. Force equals mass times acceleration. You can put that into a lovely triangle. F is at the top, m times A out the bottom, cover up the one you're looking for, and the position of the other two tells you what to actually do. So here I've got a vehicle, its mass is 150 kilos, the resultant force, pushing it to the right, is 50 newtons, so the acceleration is force divided by mass, it's 50 divided by 150, which is 0.33 meters per second squared. Compare that to a heavier vehicle. Its mass is 250 kilos, same force, but because it's heavier, the acceleration is slower. It's 50, but it's divided by a bigger number, so the acceleration is slower. It's 0.2 meters per second squared. So acceleration is force divided by mass. But hang on a minute, haven't we already decided that acceleration is change in velocity divided by the time taken for the change? We've got two equations now that tell us how to calculate acceleration. So do you see then that there are two ways of calculating acceleration? It depends upon the data you've been given. If you've been given the change in velocity and the time, then you use one equation. If you've been given force and mass, then you use the other equation. But the thing that's in common is the unit of acceleration is always the same, meters per second squared.